Hello, everyone. Welcome to Sensors for the Web. I'm Mrunal. Um, I work at Intel over here in Bay Area. I don't know if someone want to get that door, but that's fine. Okay. Um, so I work at Intel over here as a software engineer, working on the web team. So I've been working on browsers and web for more than last 10 years in Bay Area. I started working at Adobe, working on Dreamweaver, which I'm sure all of you have heard about. It's a web authoring tool. Then I worked at Palm, working on WebOS, working for browser and web platform. And then I joined Intel, working for Tizen, another web-based operating system, and Crosswalk, which is a web runtime based off of Chromium. So just to give you a brief overview of what my team at Intel does. Web team actively works with W3C, working on standardizing new as well as existing features on the web. And we try to implement that in the browsers, primarily in Chromium, which is open source browser. So we love Chromium. We working on currently we are working on generic sensor API, some of the depth camera API. We worked on WebNFC, web app manifest, which is the important cornerstone of progressive web apps. Might have forgotten to turn on the mic. Can you guys hear me? Sorry, I'm checking that a bit late. And the last bit, wake lock API, that's the API which I'm personally working on. So we have a team based in Finland and China, so they're spread across the world. So we're working on different APIs and implementing those features in Chromium. And some of the team members also work on Firefox, I believe. So that's about my team. So just to give you a brief overview of what I will talk about. Before that, has anyone ever heard of generic sensor API over here? Okay, quite a few. So nice. So we already know what the generic sensor API is a little bit. So I'll talk about sensors and its current use cases, how sensors are used in different devices. I'll talk about that, and current API, which allows you access to sensors and its limitations. And then I will introduce generic sensor API and how it tries to overcome or solve some of its limitations. And then I'll go a little bit into future work, what new sensors we are adding, and then I'll open up the floor for Q&A at the end. Just brief disclaimer, I mean, I personally haven't worked on generic sensor API. So my colleagues in Finland, they have worked on generic sensor API. I'm trying to represent their work because they couldn't be here over here to talk about generic sensor API. So I'll try my best to explain and try to explain benefits of generic sensor API as much as I can. So moving on, so sensors are pretty much everywhere. Almost all the devices these use different kinds of sensors, whether it is gyroscope, accelerometer, or ambient light sensors. They are pretty much everywhere. And various apps use it in various forms. They use one sensor, or they'll use multiple sensors. But the idea is sensors are everywhere. Even some of the devices which I haven't shown is like wearables. So even your watches or wearable devices have accelerometer or gyroscope to measure your step movement. So this is one use case which I wanted to highlight. Is so if you are building a game, for example, really nice high quality graphics game, then you will take advantage of accelerometer or gyroscope to find out how your device is oriented. So in that case, you need access to sensor data. Um, and then in this case, you might also want to find out what the relative orientation of your device is. So in that case, you might need sensor data from multiple sensors. So let's look at some of the sensor types, what kind of sensors are available. So typically, sensors are categorized into two major types. One is motion sensors, and another is the environmental sensors, which I will talk about in next slide. So motion sensors are like accelerometer, gyroscope, orientation sensor, which gives you how your device is oriented, which takes data from accelerometer and gyroscope, essentially. And so they provide data such as device orientation. So as user input, so as you saw in the previous slide, you could sense from the device movement, you can get the orientation data, how the device is oriented, and then you can control the steering wheel of the game. And then sensors could be used in VR or AR tracking. So if you're in a room wearing AR or VR headset, you would want to know how your device is oriented. So in that case, you would need data from these sensors. Also in indoor mapping and navigation. So if you're in a room and you would want to, or even outside, and you want to know where you're oriented or where you are walking or traveling, then that could be useful in navigation applications. Also, other applications could be photo and video capture image stabilization. So if there is a small shake while taking a video or image, you might want to use that and adjust or stabilize your image. Also in wearables, so you can use it for step counting or monitoring of other physical activities. So these are some of the use cases for motion sensors. And then there are other environmental sensors like ambient light. So depending on the surrounding light in the room or environment, you might want to adjust the brightness of your display or brightness of your application. And then there is a magnetometer, which senses the magnetic activity around the device. So this could be useful to find out true north if you want to find out where your device is oriented. So that could be useful, as well as I think the cardboard controller also uses a magnetometer to get the input from the input. I don't know if you've seen cardboard controller, but on the left side there is a switch. So depending on that, it creates magnetic noise. So they use that as a way to see if that control has been triggered or not. So these are some of the sensors which you can use in most of the devices today. But let's look at how you can access these sensors on the web today. So currently there is device orientation event specification. Through that you can get device motion and device orientation data. So you can get how the device is oriented and how fast it is moving, and get its angular velocity. So there is a spec for that. It was written some time back. So that's how pretty much you can access this data about sensors. But it has its inherent limitations. So it was designed some time back. So I will go through what are its limitations. One of the limitation is the frequency is hard-coded. So you can poll the sensors at 60 hertz. So you cannot adjust your polling frequency. So for example, in the left side, you can see application. It's a simple navigation or mapping app. It's trying to use ambient light sensor to adjust the brightness of the screen. So for ambient light purposes, you may not want to poll at 60 hertz all the time. That would drain the battery really fast. Whereas if you have a really CPU or graphics intensive game and you are moving quite fast, maybe you might want to need your orientation as well as your accelerometer data at 60 hertz or maybe even at higher refresh rate. So you might want to have better control over the polling frequency, which device orientation or motion event doesn't provide. Another limitation is there are no timestamps for readings, so it doesn't provide really granular timestamps, which could be useful in gathering or syncing data from multiple sensors. So if you are trying to get data from accelerometer and gyroscope, and if they are out of sync, if their timestamps are out of sync, then you may not generate graphics or output that accurately. So for sensor fusion purposes, if you're accumulating data from multiple sensors, timestamps are really valuable. So it doesn't provide that. And since it is based on DOM events, it inherits some of the DOM event limitations. So if, for example, if you want to use your application as a Node.js application, Node.js doesn't have any DOM. So you're out of luck over here. So you cannot use it in Node.js, and there are some of the IoT applications which are trying to use Node.js, and I think other scripts like runtimes like JavaScript, so which are quite used in IoT applications. So you cannot use that in those applications. So Node.js and IoT applications cannot use device orientation motion events. One more thing which I didn't mention is it has Euler angles. So if you're trying to use device orientation, it uses Euler angles. So you need to do manual conversion in JavaScript to convert it to quaternions, which are quite popular if you're using WebGL or 3JS libraries. So that added some cost from compute point of view. Another limitation is it's difficult to extend or add new sensor types. So you cannot extend or add your fusion sensors if you want to add data or combine data from multiple sensors as per your taste. So it's very difficult to do that. And as I mentioned, you cannot add any ambient light or magnetometer sensors to device orientation event specification. So that's one limitation. Another is privacy and security. So it can be accessed. I mean, you can use device orientation motion event on HTTP. So it's not secure. It doesn't allow you to provide any permissions to the user, whether you want to block access to device orientation motion event. So you cannot do that. And also there are interoperability issues across browsers. So iOS handles these events separately. Their coordinate system is separate from how Chrome would handle or Firefox would handle. So there is a interoperability issues in the device orientation motion event. And last, the specification is not maintained. So nobody is maintaining the specification. So if you want to add any new sensors or extend it or update the specification, you cannot do that, unfortunately. So that's why some of my colleagues at Intel, they tried to come up with a new sensor API from ground up and build a new generic sensor API, which would allow you to extend or add new sensors to the API. So Mikhail and Alex, they are quite heavily involved since last couple of years with some of the Google engineers over here. Try to spec out the generic sensor API and try to implement it in Chromium. So let's look at the sensors API. And so over here, there is a base class called sensor, which is used by all the other derived sensors. So like accelerometer, gyroscope, they use some of the basic functionality provided by sensors. So sensor provides basic functionality such as the timestamp data, and also some event handlers. If so, there are on-error event handlers, or if the sensor has started or not, or it has been activated or not. So some of the basic functionalities provided by sensor, which can directly be used by all the other sensors. So you don't have to implement it if you're building your own sensor or adding the sensor. So these are some of the sensors. And then on the third level, you see there are some fusion sensors. So linear acceleration sensor depends heavily on accelerometer as well as on gyroscope, but it is derived from accelerometer. Even though you may not see a direct line that it is inheriting some of the functionality or using some of the functionality from gyroscope, it still uses data from multiple basic sensors. So in case of linear acceleration sensor, so for accelerometer also takes into account Earth's gravity. So if you don't want to take Earth's gravity into account, then probably you might want to have just linear acceleration readings. So you can create a linear acceleration sensor for it and just filter out the Earth gravity field from it. Similarly, you have absolute orientation sensor and relative orientation sensor. So they derive from the orientation sensor. Orientation sensor provides where your device is oriented, like angular velocity and things like that. So there are two different types. One is absolute and relative. So absolute orientation sensor uses the Earth coordinate system. So if you're just using device without any, not motion, but as it is, if you want to use the device, it will give you the absolute orientation data. Whereas relative orientation sensor, if you're starting device in certain angle and you want to use this same reference as a starting point and then orient your device relative to the initial reference, then you can get that relative orientation data from relative orientation sensor. I'll go into the implementation. Oops. A little bit, in the next slide. But just to highlight the advantages, so what are some of the improvements of generic sensor API over the device orientation event specification? So the API or the interface is consistent across different sensors. So you get some basic functionality like timestamp or event handlers, which you can use across different sensors. And you can extend the interface and add new derived classes or derived sensors or fusion sensors if you want. And you have a configurable sensor options. So currently, as part of sensor options, which is a kind of dictionary data item as part of sensor options, so you can control the frequency, but you can extend and add any other sensor option you might want to add by updating the sensor options field. So currently it has frequency data. Then you have a better error reporting. So there is a dedicated on-error event handler for that. So which provides you better error reporting and error handling. And then there are well-defined sensor data models, which uses some of the common functionality across different sensors. As I mentioned, some of the event handlers, some of the on-activate, so if the sensor has been activated or not, and things like that. And it also synchronizes the screen coordinates. So if you want to have different screen coordinates, so there are two major types of screen coordinates, which I will go into in next slide. So one is device coordinate and screen coordinate. So if you want to sync your app to one particular coordinate system over another, you can do that by specifying the coordinate system. And it provides better security and privacy by implementing, as you can only access this as part of HTTPS. Uh, so you cannot access it on HTTP, so it's much more secure. And it's also gated behind permissions API. So if you want to have a granular permissions level for your sensors, you can do that through permissions API. And then it's also controlled via feature policy. So if you want to limit access to iframe or other third-party sites, then you can do that through feature policy as well. So let's look into the interface, how it looks like. So as you can see, it has timestamp data and basic event handlers implemented already. So this basic functionality is used by all the other sensors like accelerometer and gyroscope. So you have the on activate and as a reading or not. So if there is a reading for the sensor available or not. So you can get that data from there. You can get a timestamp data. It's a DOM high resolution timestamp. And then you get explicit start and stop functions. So if you want to start and stop your sensor readings at a particular function in the code, you can do that. So you have a more control over there. And you have a dedicated on error event handlers for handling error reporting or handling errors. And then you have a sensor option called frequency. So you can specify your frequency over there. So as you can see, accelerometer sensor was really easy to implement. You just need additional X, Y, and Z coordinates to get the coordinate data into accelerometer. So if you want to add your own sensors, it's very easy to extend the base sensor functionality into a derived sensor. So here's a code snippet, how you can create a new accelerometer in your code. So currently the frequency is hard-coded. In this example, it's 60, but in the current implementation in Chrome, you cannot specify frequency more than 60 hertz. So there are some security issues if you want to specify frequency more than 60 hertz, for example. So there was, I think, some security loophole exposed by, if you're polling at higher frequency, you can, from the tap of the screen taps, you can get data on how which input user has input pressed. So that's why, because of security limitations, the frequency is currently capped at 60 hertz. But in the current implementation, that max cap could be lifted and increased to more than 60 hertz for gaming applications or for even VR or AR applications. So as you can see, you can start and stop the sensor readings, and you can implement on reading handler and get the XYZ coordinates. And you can also implement your on error event handler. And you can create multiple sensors. Like in this case, there is an orientation sensor. So what it just needs is the quaternion data, like where your device is oriented and by how much degrees. So you can get that data in the quaternion format, and you can use this the populate matrix function if you want to use it data like matrix rotation. If you want to perform certain rotation on the data, you can do that using populate matrix function. And then there are other fusion sensors like absolute orientation sensor and relative orientation sensor. So absolute orientation sensor will just give you, as I mentioned earlier, will just give you orientation readings with respect to the device without considering the initial reference. But if you want the initial reference position or orientation of your device as your reference, and then rotate accordingly from this initial reference, you might want to use the relative orientation sensor for that. I'll just you mentioned the orientation sensor. So it's similar to accelerometer. You can specify the frequency and implement. And if you want to rotate the matrix, you can use the populate matrix function, and you can start and stop readings as per your discretion. So. And then, so as I mentioned earlier, you can specify which coordinate system you want to use. So there are two different device coordinate systems. One is device and one is screen. So not sure if it is really clear in this picture, but in the device coordinate system, it uses earth coordinates. So in this case, your Y is pointing towards magnetic north, X is towards the earth plane, and Z is pointing in the sky. So device coordinate system uses earth coordinate system. But if you are orienting your device, if you want to hold your device in landscape orientation, you can specify it to be taking screen coordinate system. So you can choose between different frame coordinate systems, either screen or device, to choose how you want to get your orientation data. And the implementation is also quite straightforward in Chromium. It uses some of the Mojo IPC to access sensor implementation in the browser. And as you can see, you can implement multiple sensor, and you can spawn any sensor instances as you want. And most of the sensors implementation on the Blink side doesn't take more than 100 lines of code to implement a new sensor. So it's really easy to implement and add new sensors. And you can access generic sensor classes currently, starting from Chrome 67. So I think Chrome 67 is in developer channel now. So,
developer channel, sorry.
Yeah, it's developer channel.
But it's going to be in beta next week.
Yeah, correct. So you can start using it from Chrome 67. The origin trial just recently ended, so it will be enabled by default from Chrome 67 onwards. But that applies only to generic sensor or motion sensor flags. From generic sensor extra classes, I think they are still under origin trial. So you can use that hopefully very soon. And I think Firefox has shown their positive interest in implementing generic sensor. I don't know how they have implemented in Firefox, but they're definitely shown positive interest on Firefox. But I don't think there are any sensor APIs implemented on iOS or other browsers, but there are polyfill options available on both iOS and Android. You're welcome to check out this link. I don't know if you can see that, but I think the slides will be posted later. So you can use that link if you want to check out some of the polyfill options on other platforms. And so since it doesn't rely on DOM, generic sensor APIs can be used for embedded applications. So you can use Node.js in some of the IoT-based applications. You can see some of the examples in Ziffer. I don't know, has anyone come across Ziffer.js before? Okay, so Intel started this project some time back. It's based off of, I think, JReScript. It's a really small runtime which uses, I think, Node.js, a small memory footprint of Node.js. So you can use that to build applications for IoT devices. So you can build that using, and you can access generic sensor APIs over there. And then future work, my team is working on adding some new sensor classes such as proximity and gravity. So I think it's still, the details are still being spec'd out. And if you want to see some of the open issues and W3C level at the spec level, you're welcome to check out that link. And you're welcome to participate in making the generic sensor API better or adding new sensors to it. So I think these links are helpful to check out at W3C, as well as if you want to check out some of the open issues at the spec level, there is a GitHub link. And if you want to work on some of the Chromium issues or just want to browse some of the open Chromium issues, you can look up under Blink / sensor. So you're welcome to check out the issue list. And I think the first link is one of my favorite. So Mikhail and Alexander, they wrote a really nice article on developers.google.com to talk about sensors for the web, which really nicely explains how sensors could be used in your application and how you can extend or add new sensors to generic sensor API. So you're welcome to check out that link and article. Some of the demos are available on GitHub at intel.github.io/generic sensor demos. And if you want to provide some feedback about generic sensor API, you're welcome to provide feedback. And if you want to contact developers directly, Mikhail and Alexander, you can contact them at the email address over there. And that's it. Sorry, I ran a little bit over time, but yeah.
Yeah, just a quick comment on that Web Fundamentals article. I think it was supposed to have been updated a couple of weeks ago because of the fact that that's going to be shortly coming out in beta.
Yeah.
But we're going to link to it in the beta blog post. So if you happen to find errors in that article, please let us know. You can either open an issue on GitHub or ping me. My email address is jmedley@google.com.
Cool. Thank you.
Welcome.
Yeah.
Note that for AR and VR, which are mentioned several times, is WebXR API.
Yeah, that's awesome. Yeah, it's good that you mentioned that. So WebXR API is using, WebXR spec is using some of the orientation sensor data. Or, I mean, some of the absolute and relative orientation sensors.
Using the underlying implementation.
Sorry, which implementation?
Using underlying sensors and stuff for services, but it's not using.
Oh, it's not using the API, but I was told it's using. I mean, last.
There's a polyfill of WebXR that you guys, but in Chrome code that implements this.
Yeah, I mean, last time when I checked the WebXR spec, which is still in development, I think work in progress, they're planning to use some of that sensor APIs, absolute orientation.
There are polyfills. Polyfills are.
Oh, okay. So you're suggesting they should be using. Oh, okay. Yeah, I mean, okay. I'll check how they are implemented. Sorry?
No more magnet in cardboard. That's.
Oh, okay. V1, yeah, the first generation. Yeah, I just tried to illustrate some of the example. Yeah. Yeah. Yeah, correct. So that's just try to illustrate some of the examples. You can use magnetometer. Any other questions? Cool. Thank you. Thank you for listening, and thank you for coming to this presentation. Yeah.